Hi all, welcome to ugcnet. In this video, let's learn about how to eliminate left recursion from a given grammar. So, what do you mean by left recursion? Left recursion means if our grammar contains a production of the form A produces A alpha bar beta, then that grammar is said to be left recursive. For example, if our grammar is like A produces A B bar C, here we can see that the left hand side of the production is capital letter A, the variable or the non-terminal A. And here in the right hand side of the production, this term also starts with that same variable A. And hence we can say that this production is left recursive. Similarly, let's consider another production. S produces S, X, Y bar C. Here also we can see that the left hand side of the production is the variable on the non-terminal S, capital S, and in the right hand side it starts with the same variable S itself, right? So we can say that this production is also left recursive. Again, let's consider another production. X produces Y, X bar A. Just have a look at this production and say whether this production is left recursive or not. This production is not left recursive because the left hand side of the production is the variable X, but the right hand side starts with the variable Y. It doesn't start with X, it starts with the variable Y. Hence, we can say that this production is not left recursive. Clear? Here you can see that in this given format, there are only two productions. One is A produces A alpha and the other is A produces beta, right? So here there are two productions. But it is not compulsory that it should be two productions itself. It can be three production, it can be four production, it can be any number of production. As well as it can be a single production too. I mean, you can skip this beta portion. Even if it doesn't contain beta, that means if the production is of the form A alpha, then also that production is left recursive. For example, if the production is like S produces S, B, C. Here we can say that this production is left recursive because the left hand side is the variable or the non-terminal capital S, as well as the right hand side starts with the variable S. So we can say that this production is left recursive even if we don't have the second production. That means the beta portion. Even if it doesn't contain a beta portion, we can say that this grammar or this production is left recursive. Clear? Similarly, you can have any number of productions. For example, S produces S A B C bar S B bar S A C. This production is left recursive because here you have three productions. In each of these production, you can see that the left hand side as well as the starting of the right hand side is same. Similarly, if you write ABC bar XY bar X, this production also we can say that it is left recursive because here you can see that in ABC, XY and X, in these three productions, they doesn't start with capital S. But the first three productions, first, second and the third production, they start with the variable or the non-terminal S. So from the given list of production, even a single production starts with the variable that is on the left hand side of the production, then we can call that production as left recursive or that grammar as left recursive grammar. Also please note that the order is not important. That means it doesn't require that the first production should be left recursive. If the production is like S produces XY bar SB, then also we can say that this production is left recursive because the order is not important. Here we can consider this as A alpha and XY as beta. Okay. So in general, we can say that if any production is of the form A produces A alpha bar beta, then that grammar is left recursive. Now, how can we eliminate this left recursion? To eliminate left recursion, we have to convert this grammar into the following form. That means we have to convert this grammar into the form A produces beta A dash and A dash produces alpha A dash bar epsilon. So actually you have to by heart these two productions. If you are not understanding this, don't worry. Everything will be clear once you start doing the problems. Okay. So now just understand that if a grammar is of the form A produces A alpha bar beta, then we call that grammar left recursive. And in order to eliminate that left recursion from that grammar, we have to convert that production into this form. A produces beta A dash and A dash produces alpha A dash bar epsilon. Here the variable A dash, it is a new variable that is introduced by us. Okay, so let's consider one example. Question 1. Suppose that our grammar is B produces BC bar D. This is of the form A produces A alpha bar beta. So here in case of A we have capital B, and in case of alpha we have small letter c, the terminal C, and in case of beta we have the terminal D. So we can just write it down here. Alpha means this is A and this is alpha. That means here you have the variable capital B. Here in this production, whatever comes after B, that is our alpha. And the term which doesn't start with B is our beta. Okay. So here alpha means small letter C and beta is small letter D. So how can we eliminate the left recursion? In order to eliminate left recursion, we have to convert it to the form A produces beta A dash, right? But instead of A, here we have B. So B produces beta A dash. Beta means here the beta is small letter D. So instead of beta, you have to write D. And what comes next? A dash. Here instead of A, we have B. So here we have to write B dash. So this is the first production, and the second production is A dash produces alpha A dash. So here instead of A dash, we have B dash. So B dash produces alpha B dash. Alpha B dash. So what's the value of alpha? Here alpha is C, right? So instead of alpha, you can write small letter C. C B dash bar epsilon. So now you can see that we have eliminated the left recursion. Just see in the first production, it is B produces D B dash. So here this term doesn't start with capital B. So the first production is free from left recursion. And in case of the second production also, B dash produces C B dash. That means it doesn't start with B dash. And here also it is epsilon. It doesn't start with B dash. So second production is also free from left recursion. Thus we eliminated left recursion from the given grammar. Let's take another example. Question 2. A produces A B D bar A bar A and B produces B bar epsilon. So this is our given grammar. Let's check whether this given grammar is left recursive or not. In this first production, A produces ABD bar A bar A, that it's clear that it is left recursive because here the left hand side is capital A and here in the right hand side, in two of the productions, it starts with capital A. So it is left recursive. So we have to eliminate left recursion from this production. Now let's check the second production. Capital B produces B bar epsilon. Here this production is not left recursive. Why? Because here the left hand side is capital B. I mean the variable or the non-terminal B. But here in right hand side, none of the production starts with capital B. So this production is not left recursive. So we don't want to convert this production. We have to convert only the first production. So let's take the first production. A produces ABD bar AA bar A. Here we can see that the third term, small letter A only, this third term doesn't start with capital A. So whatever terms that doesn't start with capital A, that term is our beta term. So here there is only one beta term. So we can call it as beta. Now what is the value of alpha? Here you can see that our left hand side is capital A and here two productions are starting with the same variable A. So in these two productions, we have to consider alpha. So alpha means whatever comes after capital A, that is our alpha. So here we have two alphas, alpha 1 and alpha 2. In this first term, whatever comes after A is our alpha 1 and here whatever comes after this capital A is our alpha 2. So it's clear that alpha 1 is B, D, alpha 2 is A and beta is A. Okay. So our production becomes, what's the format? Here it is. A produces beta A dash. So we can write it as A produces beta A dash. Beta means here the value of beta is A. So we have to write it as A. So A produces A dash. Now we have to write the second production. A dash produces. Actually the general format is A dash produces alpha A dash bar epsilon, right? But here we know that we have two alphas, alpha 1 and alpha 2. So how we will write? We have to write it as alpha 1 A dash bar alpha 2 A dash bar epsilon. So what's the value of alpha 1 and alpha 2? We know that alpha 1 is BD. So instead of alpha 1, you can write it as BD. BD A dash. And second term is alpha 2 A dash. So instead of alpha 2, you can write small letter A. So you can write it as A dash. So this is our final production. And this production, B produces B bar epsilon. That we can write it just like that only, B bar epsilon. Because it doesn't contain any left recursion, so we don't have to convert that production. You can write that production as it is. So now I hope that you have understood what is left recursion and how you can eliminate the left recursion from that given grammar, right? So in the next video, we'll be doing some more examples on left recursion and we'll be also dealing with indirect left recursion. Okay, so stay tuned. Till then, bye.